We're going to continue talking about transformations today, and we're going to be focusing today on dilations. And I want you to remember that these first three transformations that we did created figures that were congruent to the original figure. So those were all the same shape and the same size. Dilations don't create figures that are congruent. They create figures that are similar. So similar figures have the same shape, but they're not the same size. We're going to resize these objects by dilating them. It's kind of like your eye. If your eye dilates, that means your pupil either gets smaller or larger depending on how much light's in the room. So your pupil resizes. And that's what we're going to be doing to these geometric shapes. We're going to resize them. So let's get our notes page out here and take our notes on dilations. So the definition of a dilation is to resize a figure or reduce it or enlarge it, make it smaller or bigger. And the other vocabulary word that you're going to need to know for dilations is scale factor. And that's the number that we're going to multiply each vertex by in order to resize or dilate the figure. A scale factor that is greater than 1 will enlarge the figure. So for example, if you multiply your vertices by 2, that's going to make the figure bigger. But a scale factor that's less than 1 will reduce the figure. So if you multiply your vertices by, let's say, 1/2, you're going to make that figure smaller. So let's take a look here at how we're going to dilate figures. So the first thing that you'll do is you'll multiply each coordinate by the scale factor that they give you. They'll always give you a scale factor when they ask you to dilate. So you'll multiply each coordinate by that given scale factor. You'll plot the new coordinates. Make sure you label each coordinate with that new coordinate with a prime mark. Connect the points to recreate the figure. And this is here what I was talking about earlier. The new figure will be similar to the original figure, not congruent. It should be the same shape, but it'll be a different size. So let's look at the first example here. We've got a triangle that has vertices of -2, -1, 1, 1, and 2, -3. It says find the coordinates of the vertices of the triangle after a dilation with a scale factor of 2. So all we need to do here is take each of our original coordinates and multiply it by the scale factor. So we're going to multiply both of these by 2. So the new C coordinate will be, if I do 2 times -2, I get -4. And then if I do 2 times -1, I get -2. So the new C prime will be -4, -2. Then we're going to do that also with D. So I've got 1, 1, and I'm going to multiply it by the scale factor, which is 2. So I'll multiply 2 times 1, and then 2 times 1 again. So my new D coordinate, D prime, is 2, 2. Then on the third one, E, the original coordinate was 2, -3. I'm going to multiply each one of those by that scale factor. So multiply it by 2. And kind of like the distributive property here, I'm going to be multiplying both of them by 2. So E prime, 2 times 2 is 4, and 2 times -3 is -6. So those are my new coordinates, and I could graph those. I'm not going to graph them on this one because they said just find the coordinates. Okay, in example number 2, it says find the coordinates of the vertices of each figure after a dilation with the given scale factor k. Sometimes they'll call the scale factor k. Then graph the original image and the dilation. Well, my scale factor is right here. It's 1/2. And so I'm going to be multiplying each one of these coordinates by 1/2. Every one of them gets multiplied by half. So the new f coordinate, f prime, half of -4 is -2, and half of -6 is -3. So that's my new f coordinate. G prime, if I multiply each one of those by half, half of -4 is -2, and half of 4 is +2. Then h prime, half of 4 is 2, and half of -6 is -3. If I go back to my directions, I'm supposed to graph the original image and the dilation here on my coordinate plane. So let's do that now. So if I graph my original image, -4, left 4, down 6 is right there. Let's label that with F. Then G is -4, 4. So it's up here. So that's left 4, up 4 from the origin. And then H is right 4 and down 6. So this is H. So let's connect our points and make our triangle. Since it has 3 vertices, it'll be a triangle. Now I'm going to graph the dilation, the dilated figure. And since I multiplied by a scale factor of 1/2, this new figure will be smaller than the original figure. So let's graph -2, -3 for f prime. So that's left 2, down 3. So that's f prime. G prime, left 2, up 2. So that's G prime. And then H prime is right 2, down 3. So there's H prime. So when I graph this one, you will kind of have a triangle inside of a triangle. Now I want you to notice something here, kind of that what we learned about slope is that if my lines were straight, this hypotenuse of this right triangle here would be exactly on top of the hypotenuse of the other right triangle. And that's because those triangles are similar. And so, like for instance here, the slope of the big triangle, rise over run, would be 10/8, which reduces to 5/4. Then if I look at my new triangle, I've got a rise of 5 and a run of 4, so they have the same slope. And that will always happen on dilation. 10/8 is the same thing as 5/4. So they should have the same slope when you're finished. Okay, the last thing we want to do is describe the transformation that is done here in example number 1. Well, we can already tell that this is definitely a dilation because the original figure got smaller. It's not congruent. The new figure is not congruent to the original figure, so it definitely has to be a dilation. Dilation is the only thing that can make it bigger or smaller. Can't be a rotation or a translation or a reflection, because those would be congruent. The hardest thing to do here on this is figure out what the scale factor is. Now I know that the original figure is bigger than the new figure. So I know that the scale factor has to be a fraction. It's got to be something less than 1. But here's how you can figure out what the scale factor is. So to find the scale factor, what you're going to do is take one of the new points and put it over one of the original. So for example, let's just pick W prime. W prime, that coordinate is 1, 2. And then I need to pick also the original W. The original W is 4, 8. So if I take one of those new coordinates and put it over the old one, the scale factor is 1 over 4. Now I could have done it with 2 over 8 because 2 over 8 reduces to 1/4. So it doesn't matter if I use x, then I could put a new x over the original x or a new y over the original y. Doesn't matter, I should get the same scale factor. So the scale factor is 1/4. So this is a dilation of with a scale factor of 1/4. Okay, the last example here says Zach has a toy bicycle that's 2 inches tall and an actual bicycle that is 16 inches tall. What is the scale factor of the dilation from the toy to the actual bicycle? So I want to put the new over the original. That's how I find scale factor. You might want to write scale factor equals new over original. It's kind of the formula for scale factor always. Well, I know that because it says from the toy, I know that the toy is the original. And the toy was 2 inches tall. So that's going to go in place of the original. So the scale factor, the original toy was 2 inches tall. And then the actual bike was 16 inches tall. So I put 16 over 2, and then just go ahead and divide that. 16 divided by 2 is 8. So the scale factor is 8. So that means that the actual bicycle is 8 times bigger than the toy bicycle.